It's something that makes you feel smart in those situations.
Yes, this is physics actually.
Ay, Jesús.
Why can you send me move here?
I think.
Yo, do you see lessons
Yo, but we need
Okay,
change.
so who's filming?
Yo.
Okay, so up to now we've been doing polar coordinates and rectangular coordinates, right?
Yeah.
And the word vector has not come up except when I tell you, or I've told you, that that's how you write vectors, remember? And I told you that this is polar, for example, 6 to the 215 degrees, and you know that it's here, right? And I always tell you, please write an arrow. Please do it, put it in a Cartesian plane so you know where it is, right? And I also tell you to put the magnitude here and to put the direction here, right? Another way of writing this is the rectangular coordinates, which would be,
Mister, would it be 35, not 30?
it is a 30.
Oh, it looks like a 30.
And remember that this is a way of telling you how to get here, to this point, right? Because you go 215, which you start counting from here, and then you go 6 this way until you get to this. With rectangular, you are going to get to the same point, but they give it to you in a different way. So they tell you, for example, it's going to be 3 to the right plus 4 up. Actually, this would be to the minus 3, minus 4, right? Or minus 3i, this was the international way of doing it. So what would you do? Well, you're still going to get to here, but you're going to do it this way. You're going to go here first,
And 4 down.
and 4 down, which in the end gets you here, right? So this would be 3 and 4, okay?
Yeah.
Now,
And H.
right now all of this is just numbers and math. Where do you actually use this? Well, this was devised for physics. Because forces, do you know what a force is? What's a force?
Something that moves.
Something that
Something that moves because it's got its acceleration very good. And is it the same if an elephant hits a wall or if a mouse hits a wall? Which one's going to have more force?
Elephant.
The elephant, because it has more mass. And that's when Newton came up with force equals mass times acceleration. Because the faster you go, the harder you're going to hit it, right? Especially if you're accelerating. If you're going faster, 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 you're going to hit it harder than if you're just going at a constant speed and no acceleration. Does that make sense? Wow. So you know what a force is. Now, where do you see forces? If I do this on Ian, am I applying a force?
Yes.
Yes. How about me just standing here on top of this on the floor?
Yes.
My weight is exerting a force on the floor, right? I'm not going to do it hard, but I need your hair because it's the only string I have. Okay? If I do this, if I push her hair, am I exerting a force?
No.
No. But if I pull it,
Oh.
this gets tense. I'm going to do it here so it
Miss,
doesn't.
what if you cut it?
It gets focus. It gets tense, right? And if it gets tense, if I do this, I'm exerting a force in which direction? So the direction does matter. Because guys, the direction does matter. Because if I do it in this direction, there's no force. But if I do it in this direction, if I pull, there's a force. This would be, let's say that this is positive, then this would be
Negative.
okay. If it were negative, then I would have to push here and pull this way, and that would be the negative force. Because if I just do it here, there's no force. But if I pull this way, so this is the negative and this is the positive. Does that make sense?
That could be negative force.
But,
Miss, should have recorded
So-
it in the video.
how are we going to do it here? they're going to tell you the following. Look at example 78.1.
Two ropes are attached to a point and both on the directions and magnitude shown. What is the resultant force on the point?
Okay, so there's two ropes pulling on the same point. I'm going to draw them in two different colors so that it's easy to see. This rope is pulling this way. My arrow, I'm not going to draw the rope, I'm going to draw the arrow in which the force is pulling. Ropes always have to pull towards the outside because if not, it's like Carly's hair. If there's no tension, there's no force, correct? And this is going to be 30 degrees, bless you,
Why 30?
because
Because
that's
right
what
there.
they tell me.
Awesome.
And this one is going to be 45. Why, Seth? Why is it 45?
Because it tells you.
Ma. So, this is 70 newtons. Forces are given in newtons. And this is 40, and this is 40 newtons. Okay. Now, if I have to translate that, this is like saying that you have 70. Would this be 45?
Yes.
If I put it in polar?
No.
What would it be?
135.
Very good. This would be 135.
We go 90 minus 45.
And they're telling, and you have another one that is how much?
48.
Fine. So this is translating into language we know. So this is nothing new, except they're not giving it to you like that. They're already giving you the drawing. Okay?
Yeah.
So I'm going to translate that drawing into my graph, which I know, which is 45 here, my arrow, and my 70, and 40 here, and my 30 here. Now, I'm going to use you again. Please stand up, Ian.
Exactly the same.
Oh yeah, yeah, you're gonna finish the video.
Martin, can you stand
He
up?
doesn't.
Ian, you can stand here in front of the camera, and you, we're gonna leave it. We're gonna pull. Just pull it. Just
What?
pull his arm, okay?
He's mine.
He is probably stronger than me. He's taller. And he's a guy.
He's a guy.
And he uses my sport.
And you
Pull,
want
pull. Okay. Now, because we're both at an angle and we're both pulling, right? Okay. Stop. Thank you. I don't know if you saw enough, but you saw that he tended to move that way, right? Because he's stronger. And because the result of both our forces, even though I was pulling this way, he was pulling that way, his was probably larger. The result, in general, was probably going in that direction. So what you're going to find right now is the resultant, or the total, of those two forces pulling in opposite directions at different angles. How do you do that? Same way you've always done. This one is going to be, can you add it if it's in polar? No. You've got to pass it to x's and y's. You've got to pass it to rectangular. So you're going to have what you've always done, which is 40
cosine of 30 and 40 sine of 30.
But instead of drawing it here, I'm going to put it here, okay?
It's the same thing.
It's the same thing. 40 sine of 30. Is it a problem for you if I put it here instead of here? No, you know what it's about, right?
Yeah.
And why? Okay. And the other one is going to be
70 cosine of 45 and 70 sine of 45.
and it's going to be here, right? Because it would be here.
Negative. That's 7 equals 45.
Now, this one would go down this way, right?
Uh-huh.
I know, it's up here.
Yeah.
My bad. It's up here. This is 70 sine of 45.
I don't know.
Does somebody not understand why I put 70 sine of 45 here? You all good? Fine. So now, and this is the key, please be organized here. You're going to do the sum of forces in x
Yeah, I like that one.
and the sum of forces in y. Okay?
Yeah.
Because we are talking about forces, and remember this symbol means sum.
Yeah.
Okay? What do you have in x?
70 equals.
Always put the positive first.
Oh, yeah, 40 equals of 30.
40 cosine of 30
Negative 70.
minus 70 because that one's going in the opposite direction. And remember that the signs here are direction. And this one we have.
Plus and plus or no?
Very good. 70 sine of 45 plus 40 sine of 30. They're both plus. Why are they both plus?
Because they're in.
Because
they're
they're
going
going
up.
Because they're both going up. And you can easily see it if you have a diagram. Remember, I'm always telling you, please put both things on the same diagram, not separately. This is why, because it's easy to see what goes together, okay?
Yeah.
Once you have this, I think you know how to do this. But let's find out the amounts, shall we? Can you please take out calculators so I don't have to do this on my own? Make sure they're in degrees and not in radians. 40 cosine 30. Somebody do the rest.
34.34.
4.6. What's the next one?
And
70 cosine 45. Somebody do the other two so that
I
Cosine
the
of what?
total is not minus
No, I won't go.
14.86.
The total.
49.49. 49.49.
49, yeah.
Okay, so the total can't be that. This one.
Why?
You just added.
70 what? Sine? 45.
70 sine 45.
And
49.45.
49.49. And this one?
40
plus?
sine of 30.
40 sine 30.
it's 34 point, 34.64.
60. No points. It can't be.
Yeah.
20, I got 20.
Oh,
Yeah,
I
that's
put
22.
sign. It's like
Huh?
20.
20.
20. Ah. So the total here is minus what?
30.
Negative 24.
25.98.
98. And this one is probably what Seth said. No?
No.
69.49. Okay.
That's,
Now.
I got minus 14.85.
Okay, so what does this mean?
14.8.
Yeah, Ian got it wrong.
Minus 14.8. Thank you.
minus
I told him that was what I said at first.
Right. Thank you, Seth. Now,
Alam yan.
what do you do with that information? What does it mean? What are we finding? If we have two forces, we're trying to find the total that made Ian move. Right?
Yeah.
We're trying to find the result of that force, but expressing it as one single force. If I had to apply one single force and get the same result, what would that single force be? Does that make sense?
Yeah.
So, it's this. But that looks all weird, so I'm going to put it so that it doesn't look so weird when I tell my workers what to do.
It's nothing new.
I have nothing new, except now use the word force. Ooh. So, we've got minus 14. Where would I put the minus 14 in x?
That way.
Here. 14.85. But miss, where's the negative?
It's going that
It's
way.
direction.
It's the direction is the arrow I put here, it's that way. Okay. And then 69.49.
It's up.
69.49. Therefore, my resultant force is where?
Top left.
Yes, there.
It's here, right? 14.85.
And then the
Okay.
Tangent.
So now I have to give the force again. How do I do it? So I find the magnitude, I find the angle.
So m squared
Very good. M squared.
equals 60.
4.49 square plus
Is it a 9 or is it 4?
69. 69.
149 squared plus 14.85 squared. Okay, and M will equal? You're not done yet? Come on.
5,049.38. But yeah, actually no, I didn't square root it. 71.06.
71.06 newtons. Okay. And then the angle is going to be the inverse tangent,
which is opposite over here.
69 over 49 over 14.85. And that will be?
69.49 divided into 14.80. What?
77.94.
Huh?
77.94.
0.94.
This,
So
am I got
this
the
is
answer?
77.94.
minus 180.
So how do I tell my workers, listen,
Alright.
don't apply two forces, only apply one, because we don't have enough strength. So we've got to do it with just one string. What would the direction of that string be and how much force?
Direction.
The force will be 71.06 newtons. In what direction?
And 77.
180 minus
Minus
77.94 equals
In what direction, guys?
102.06.
102.0.
In 102. If I could only open the markers.
Just is another call.
Miss,
No,
is
it's
it
not the color
minus
the problem. It's my hands are sweating. It's 101 way?
102.06, I think.
Yeah.
Okay, because I'm counting from here, remember?
Uh-huh.
That's it.
Oh, wow.
Excuse me, miss.
Hold on.
Okay, do we have to
Yes, because now you're giving it in force. So it's gotta be magnitude and direction.
Also, do we have to make the second graph, or can we just use the first one?
Yeah, can we only use the fish? Do we have to draw another graph?
No.
No.
Okay.
It's better if you do that one. Because when you get to physics, if you're not used to it, then you'll have a hard time. Whereas what you can do is just do this one from the start. Don't draw that one.
Okay.
This is your resultant force. Why is it the resultant? Because it's as if you were taking that, but making it into just one and getting the same result. Does that make sense?
Yeah.
Thank you so much.
Miss, excuse me, don't raise, please.
Miss, peace. Peace. Peace.
Peace.